Hello everyone, my name is Phimthong Khamjapo. Today I will present about rotational decking-based investigation of frictional property of nonwoven fabric. Here is outline. The first one is introduction. The next one experimental methods. There are testing methods, decking angle and material. And the next part is result and discussion. And the last one is conclusion. Let's start it at introduction. Uh, Nowadays, the spunbond is widely used in various sectors of manufacturing of nonwoven, so that analysis of mechanical, physical, and hand-related properties play an important role in obtaining the desired quality product. In this work, frictional characteristics of 100 polyester, nylon, and polypropylene spunbond nonwoven fabric bonded with T bonding pattern, and the difference in fabric density were tested by using viscose tactile sensing machine. Moreover, fabric property, bonding pattern, component filament, and fabric weight are also investigated. Uh, the next is experimental method. Uh, the first part is testing method. Uh, this schematic diagram shows the whisker type tactile sensor friction testing machine and its sensor unit. This machine, based on the rotational decking method, has mainly consist of the tactile sensor unit, sample state, and encoder, the speed control motor, and speed controller, and the data acquisition system. And this machine can measure friction force and normal force by taking 10 times for each kind of sample. The next is decking angle. Uh, in order to determine the friction coefficient value agent on direction of nonwoven fabric, the decking angle theta is defined at 0 degree and then become 90 degree when the sensor Y is parallel to the machine direction, as shown in the figure of relative position of sensor Y during testing. And their advantage is to detect the friction coefficients of the fabric surface in all directions within the short period. And the next is material. The spunbond nonwoven are made from a sheet of web in which synthetic long filaments are uniformly distributed and bonded by thermocompression. The samples are composed of 100% polyester, nylon, and polypropylene with three patterns as shown in the left figure. Uh, there are minus pattern, point pattern, whip, and weave pattern. However, in this work for minus pattern, the spunbond nonwoven of 100% polyester and nylon were tested. For point pattern, spunbond nonwoven of polypropylene and nylon were tested, and for weave pattern, polyester and nylon were tested. And the figure 4 show some of sample surface morphology. The next part is result and discussion. The first one is stick slip test or SST of friction coefficient and its mean deviation. For minor pattern bonding nonwoven, the regular feature of SSP of the coefficient of friction was found when the sensor Y position is perpendicular to the MD direction of sample at 180 degrees of decking angle. For point pattern bonding nonwoven, a regular stick slip tests were observed at some degree around at 45 degree, 135 degree, 225 degree, and 313 degree, where the sensor Y travel across the diagonal lines. And for the V pattern bonding nonwoven, the regularity of stick slip was observed at every 90 degree of decking angle, where the sensor Y crosses unbonding point. And the next result is effect of fabric mass per unit area. A thin and paper-like surface appear with an increase in fabric weight. However, there is no difference within polyester weave pattern spunbond fabric because this fabric look like paper. And next is effect of bonding method. The results show that there is no significant difference between minus pattern and point pattern bonding spunbond in low weight fabric. And the next effect of component filament. From the value of friction coefficient, it is difficult to interpret that not only the filament property, for instance diameter, but also the producing parameters such as bonding, temperature, and time have an influence on it. And the last one is conclusion. The specific geometric surface of its bonding pattern influence on the resultant SSP test and mean deviation test. Uh, Next is the bonding method, material, and fabric density have impact on the mean coefficient of friction. And the last one, the value of friction coefficient of polypropylene nonwoven is larger than nylon spunbond in the case of same bonding pattern and fabric density. The nylon spunbond nonwoven had a large coefficient of friction value when compared to polyester spunbond nonwoven. And the last, thank you, Professor Kinali, for your help.